Good morning, students. Myself, Dr. El Selvam, Head of the Department, Computer Science Engineering, Cyber Security, and Computer Science Engineering, AIML. In this video lecture, we are going to see about expressions and IO statements. Here we are going to cover the following topics. First one is expression, operator precedence and associativity, input-output statements, and assignment statements. Here we are going to see one by one. First, we are going to see about expressions. Expressions consist of a sequence of operator and operands. The example is total is multiplied with the tax rate. Here, total and tax rate are operands. It can be called as operands. So, that are operands and it can be expressions themselves. Here the multiplication operator symbol, asterisk symbol, is known as operator. This operation calculating a result based on the operands. Expressions, first we are going to see the arithmetic expressions. An arithmetic expression is a combination of variable, constant and operators arranged as per the syntax of the language. Example A star B minus C. This is one example. Here asterisk and minus operator takes place. Next one is m plus parenthesis m plus n multiply with parenthesis x plus y. These are two examples which shows the arithmetic expression. How to evaluate the arithmetic expressions? Expressions are evaluated using an assignment statement that follows specific rules of operator precedence and operator associativity. We will see the next slide about operator precedence and associativity. Example of evaluation of expressions. Variable is equal to expressions. Here variable will be placed in left side and then expression will be placed on right side. Here we are going to see about operator precedence and operator associativity, which is used to evaluate the arithmetic expressions. Operator precedence. Operator precedence determines which operator is performed first in an arithmetic expression with more than one operation with different precedence. This is operator precedence. Next, operator associativity. Operators associativity is used when two operators of same precedence appear in an expression. The associativity can be either left to right or right to left. We would explain this operator precedence and operator associativity with the example in next slide. Before seeing the example, we must know about the precedency and associativity of C operator. This table helps us to how the precedence and associativity of C operators will take place. There will be three columns. First column symbol, second column type of operation, third column associativity. In the first column symbol shows the so many symbols in different rows. This row, the symbols are takes place by the higher priority. First row will be having the high priority, and second row will be the next priority, and third row will be the next priority, and so on. The second column types of operation, it may be expression, unary, multiplicative, additive, parenthesis, and will be so on. Third one is associativity, whether it is left to right or right to left. The particular arithmetic expression will be working based on left to right or right to left. That will be decided based on the symbol. Here we are going to see the example how the precedence, operator precedence and associativity of C operators will take place to solve the given expression. Here the expression x is equal to 9 minus 12 divided by bracket 3 plus 3 multiplied bracket 2 minus 1. Whenever parentheses are used, the expressions within parentheses assume highest priority. Already we saw that we saw this point in our table in the previous slide. If two or more sets of parentheses appear one after another, the expression contained in the leftmost set is evaluated first and the rightmost is the last. Yes, in our example, this 3 plus 3 will be evaluated first and 2 minus 1 evaluated first. In next slide, we will see how this will be getting invoked. For example, the example sum is x is equal to 9 minus 12 divided by 3 plus 3 star 2 minus 1. The same precedence will be will be getting invoked in single pass. For example, here parentheses, 2 parentheses are there, so it will take place one pass. But each parenthesis will take place step 1, step 2. Each will take one step. So the second is same precedence, asterisk and division symbol. So it will be working on the second pass, and then final minus it will be working on the third pass. So first pass parenthesis will be getting invoked. So 3 plus 3 6. So 9 minus 12 divided by 6 asterisk 2 minus 1. The second step, the second parenthesis will be invoked. Already we know that parenthesis will be getting invoked left to right. So first 3 plus 3 invoked and then 2 minus 1 invoked. So the step 2, x is equal to 9 minus 12 divided by 6 asterisk 1. As per our operator presence, division and asterisk will be getting the second pass. Second pass, step 3 is equal to step 3, x is equal to asterisk, division, first division left to right associativity. So the 12 divided by 6 will be getting invoked. So 9 minus 2 star 1. The step 4, 9 minus 2. In third pass, the lowest priority in this expression is minus. So 9 minus 2 is equal to 7. Thus the given expressions will be getting invoked. This is the way to invoke the arithmetic expressions. Next, we are going to see about input-output statements. C programming language has the standard libraries that allows input-output in a program. The stdio.h are standard input-output library in C that has methods for input and output. Input-output built-in functions in C falls in two categories, that is formatted IO functions and unformatted IO functions. Formatted IO functions is known as formatted because we can use format functions in these functions and we can format the variables as per the user requirement. So that is formatted IO functions. And then unformatted IO functions, these functions known as unformatted IO functions because we cannot use the format functions in these functions and we cannot format the variables, input output variables according to our needs. So it is known as unformatted IO functions. Formatted IO functions, printf, performs output to the standard output device. Typically, we know that it is defined to be the monitor. It requires a format string to which we can provide specifications on how to print the values. For example, in our example, the number is %d /n, num. Here, %d is the format specifier, which is used to print the input, which is used to print the integer variables. Next, formatted input functions. Here we can use scanf function. It performs input from the standard input device, which is the keyboard by default. In some cases, it may be scanner. It requires a format string and list of variables into which the value received from the input device will be stored. Example, scanf %d ampersand size, %c ampersand next char, %f ampersand length. Here the %t, %c, %f are control strings. Format, in some cases it is known as format specifier. %d used to get the integer input from the keyboard. Percentage C used to get the character input from the keyboard. Percentage F used to get the float input from the keyboard. And then unformatted input output functions. There are so many functions. Here we are going to see about two functions, getChar and getYes. getChar, this function reads exactly one character from the keyboard until and unless the enter key is pressed. Example 2, character char ch is equal to getChar. This getChar function receives only one input from the keyboard, and later it will be stored in ch, the variable ch. Next, getYes. This function reads a group of characters or strings from the keyboard by the user, and these characters get stored in a character array. In contradiction, getChar gets received the string value from the keyboard. Example, character string str. This is variable name. Length of the string in this number. Input is length of string in number. GetYes, the string is passed as function variable. Next, unformatted output function. Here we are going to see about two functions, putChar and then putYes. putChar, this function provides for printing exactly one character to the screen. Example, the same example, char ch is equal to getChar. First we receive the value from the keyboard, single character from the keyboard, then we send that input to the screen by the putChar ch. Next, putYes, this function is used to display a group of character or strings which is already stored in a character array. Example, putYes, this is identifier name. For example, if our input is in string str, variable name str, then we have to pass str here. Finally, we are going to see about assignment statement. That assignment statements are used to assign values to variables using the assignment operator equal to. The general syntax of the assignment statement, variable name is equal to expression. Here variable name is placed left side, expression is placed at right side. Example, this is variable name, velocity is equal to 20. We can assign some value to the variables. We can assign multiple values on same line. Example, b is equal to 15, temp is equal to 12.5. We can assign the expression on right side, and then that after producing some output, that output will be stored the variable which is placed on the left side. Here a is equal to a plus 10. Here we are showing some more examples. A value can be assigned to a variable at the time of the variable is declared. It's also another method to assign the values to the variables. Int speed is equal to 30, char flag is equal to y. This is another method to assign the values to the variables. Several variables can be assigned the same value using multiple assignment operators. For example, a is equal to b is equal to c is equal to 5. This 5 will be assigned to a, b and c. Likewise, flag 1 is equal to flag 2 is equal to character y. This y value is assigned to flag 1 as well as flag 2. This is the example of assignment statements. Thank you, students. I hope you understand what I am saying here. You can expect 2 marks or 6 mark question from this topic. Thank you, students. You would see in another video. Thank you.